All right, we'll go ahead and get started. I see some folks are still rolling in, but I'll go ahead and kick us off with some introductions. So I want to thank you all for joining this webinar today. We're really excited for this session as we take a technical deep dive into the semantic layer. This is one out of several semantic layer webinar series that we at Enterprise Knowledge are hosting. And the purpose of this series is to hear directly from our EK experts about the work they are doing in this area. I'll go ahead and introduce the moderator and the panelists for today's session. Sara Mae O'Brien-Scott will be our moderator for today. Sara Mae is a senior semantic engineering consultant with Enterprise Knowledge who specializes in semantic modeling for graph implementations, and she leads teams in designing and implementing taxonomies and ontologies for solutions like recommendation engines, semantic search, and more. For our panelists, Urmi Majumder is a principal architect in the Advanced Data and Enterprise AI practice at EK, where she leads system architecture, design, and implementation of a broad range of enterprise solutions, including semantics, enterprise AI, and other scalable data management solutions. Heather Hedden is a senior consultant with EK who specializes in designing taxonomies for various client implementations and also advises on taxonomy and ontology management software. Heather is also the author of the book, The Accidental Taxonomist. And finally, Chris Marino is a seasoned solutions architect with a focus on enterprise search, AI-enhanced semantic technologies, as well as knowledge management and content management systems. He enjoys listening to clients, understanding their unique challenges, and delivering high-quality solutions that are tailored to meet their needs. We'll go ahead and get started now, but we'll make sure to leave time at the end for Q&A from the audience. Please save your questions until then and feel free to submit them in the question box throughout the session. I will be monitoring that question box as well as the chat and facilitating the Q&A at the end alongside Sara Mae. So over to you, Sara Mae.
Thanks, Madeline. Again, thanks for being here. We're really happy to share in this with you. All right, so to our questions, this first question kind of will help give us a sense of, what are the components in the semantic capabilities world. So to our panelists, what are technology components that you work with that enable semantic capabilities? And Urmi, if you don't mind kicking us off here.
Sure, thanks, Urmi. So to level set everyone's understanding, we should start with how at EK we define semantic layer, right? So here at EK, we define semantic layer as a framework that connects all your organizational knowledge and data assets to an abstraction layer, right? And then what could be a more effective way to organize all that content and data without leveraging rich and descriptive metadata. So of course we need then some sort of metadata manager, but what type of metadata manager we would require would really depend on the use case you're trying to solve, right? So for example, last year I worked on a semantic layer implementation for a large retail giant. They were trying to improve the search and discovery of their data products in the data management platform because they had published a ton of data products, but when time comes for data engineers to find like similar data products or whatnot, they can't find anything. So of course, we tackled the problem with a taxonomy, right? Like trying to improve the discoverability of all these data products. So of course, you would need a taxonomy manager, right, to organize all the organizational vocabulary in a structured format. We also included a business glossary manager, right, because that was storing all the definitions of all these the taxonomy terms, the taxonomy classes, even in that were defined in the taxonomy manager. And then we also had a data catalog to bring it all together, right? Like that could include support the search and discovery of all these data products that were tagged to the terms in the taxonomy manager, and then connect back to the definitions in the business glossary manager and bring it all together and truly power semantic search. Right, so those three were sufficient for this specific use case, but then later on in the project, they wanted to, the data engineers were coming up with the issue of, okay, using these specific criteria, I can't find exactly the data products I'm looking for. So give me, similar data products that I can probably look into, or the underlying data sets that I can utilize to build similar data products. So that's a classic graph use case, right? So then you would need an ontology manager to model all the complex relationships between data products and data sets, and of course a knowledge graph to hold the triples that corresponds to the instantiation of the ontology. So again, it really depends on what the use case is to really determine which of the semantic layer components you would pick up.
That's helpful, Urmi. And I know, Heather, you in particular have had experience in the taxonomy, ontology, and data catalog side of things. So would you care to expand on those kinds of components a bit?
Yes. So, we talked about taxonomy and ontology management. And what's interesting is that increasingly, and pretty much now, it's a single tool will do both taxonomy and ontology management. And the reason why is because taxonomies and ontologies now are based on semantic web standards. It's all based on RDF, and then taxonomies are based on SKOS, Simple Knowledge Organization System data model, and ontologies are based on RDFS and web ontology language. So they can be managed and integrated very well. In fact, where the line stops between taxonomy and starts between ontology might not be clear to all users. So that's really a necessary but very useful tool, because we're covering the scope from taxonomy through to ontology. Now, data catalogs, that's definitely different, because then, data catalog, as its name implies, is an inventory of all your data assets, and it manages the metadata of it. And we find some people have them and some clients do and some don't. It depends how data rich your organization is, whether you actually need that as well. But then there is this question about integrating with taxonomy and ontology management. Business glossary, that it's a little simpler, but there are tools for that, especially if you're going multilingual. It's called terminology management software. There's a bigger market for that, of course, in Europe and in Canada and markets where it's multilingual. But then managing the definitions and different translations and maybe multiple definitions and of terms. And this can also link to a taxonomy ontology management system. There's master data management. I'm not so familiar with that area, and maybe people will argue one way or another if that type of tool or system is a way to integrate or not. But definitely integrate, a comprehensive, we say taxonomy ontology management. We sometimes have an acronym now, TOM, to refer to such tools, because they are combined. I don't know if we're saying any vendor names or not, or we'll just let me know.
I think that was a good summary. I appreciated, Heather, how you mentioned some of the semantic standards in the context of the technology components, and some play better than others with those standards. So that's good.
There do exist still pure ontology management software, and pretty well known as an open source one, Protege, but it's it's not as good for the taxonomy management. And you can do it, but it's it's not as easy. And then there's some traditional thesaurus only software, but mostly we see them combined.
And Sara Mae, I'll kind of hop in here now and maybe take it from a little bit of a different angle in that. So my focus primarily been on kind of more of the content as opposed to strictly data. And there's a lot of similarities, but it gets to the point now where, my last 2 or 3 projects, you kind of have a set of components, technologies that you use to kind of accomplish this. They're all really fit well in the cloud. So whether you're using Azure, AWS, Google Cloud, they're really good solutions for there. Most of the services available in this cloud fit nicely. So, normally what you're looking at first is some sort of integration tool or an ETL tool, because, the key here is connecting to data sources, pulling data into to whatever whether it be your semantic layer, or on the content side, we kind of refer to it as a knowledge portal as well. As Heather stated, yes, taxonomy management offers a lot of functionality is to, be able to describe things in a uniform way, but also some benefit for things like auto tagging, which, now you're able to describe your content in the same way. A data store is also important. For the longest time, that's been a relational database, and it could still be, but there's a lot of possibilities for graph, as Urmi mentioned, whether it be RDF or property graph. I would argue that for storing data like this, what we're talking about, highly semantic, highly related, a graph works better than a relational database. And then there's usually some sort of front end, and unfortunately, there's not a lot of out-of-the-box tools that provide this front end to kind of see this data. A lot of times, we're just building a simple, JavaScript framework, whether it be React or Angular, to kind of as your presentation layer. So those are kind of, we start off and usually go through a manifest with our clients as to, hey, these are the type of technologies that you're going to build. Every project has probably some variation. They're not all required, but those are sort of the idea of the components you'll be dealing with.
Great, thanks, Chris. So now that we have a bit of a sense of the kinds of components that you're working with in the semantic layer to enable semantic capabilities, let's talk a little bit more about the architecture that is built for these solutions. I know someone mentioned for different use cases, you're using different kinds of technologies. So I'm curious to hear a little bit more about, what are some ways that you've architected semantic technologies in different environments, maybe for different purposes. And Chris, if you don't mind jumping us off here.
Yeah, and again, I'll kind of take it, I see it as kind of two, not divides, but I think the way we handle content and we deal with more content maybe varies a little bit from kind of that strictly BI and data and analytics type work that Urmi handles a lot more. So I think she could add some nice color to kind of the architecture that I'll present. So really there's kind of, I see it as 4 stages of what we have in here. We have this kind of first stage, which is a ingestion stage, which then kind of leads to a curation or an enrichment stage. From there you go on to more like a persistent stage, where's that data going to be stored, and then kind of that presentation layer. So similar to what I was describing in the components, you kind of have these 4 things that are typical for these sorts of projects. So the ingestion phase, just like it sounds, again, you're going out to data sources and connecting, pulling in information. So some of the things that you need to be aware of are just basic, like firewall issues, access issues. What are those data sources? Have you identified it? How are you going to get to them? Are there APIs available? Do you need to do data dumps, things like that? What are the security concerns? Are you able to see all the data? Are your users able to see all the data? How are you going to handle that? And then also kind of the frequency, how often is this data updated? Do you need to set up routines that pull it in, once a day, once an hour, or, if it's even more time sensitive, maybe it's, down to the minute or every few minutes. So those are some of the things that you need to figure out on the integration side. When you get to the curation side, again, this is kind of open to you as to how much or how little you need to do. So, leveraging tools like taxonomy management systems for auto tagging. There's all sorts of different NLP tools that you can use to extract entities, enrich, provide sentiment, things like that. And really where we're seeing it importantly is in connecting and relating data. As your data from different systems comes in, there's a lot of benefit, and I'll touch on it later, about how that's related. And so all those sorts of things kind of fit into the curation and the enrichment. Finally, you go into the persistent stages. Once you enrich and connect this content, where am I going to place it? And again, here I would argue that a graph is really a nice place to do that. You have a lot more flexibility than you have, with the kind of the constrictions you have with schema and relational database. And now I've added a new field and I've got to, re-import all my data and stuff. Where, graph, for the most part, you just pop it in a new field and you're good to go. What that also offers is the ability, when you think about kind of backup and disaster recovery, in truthfulness, for a lot of these systems, our backup plan is just repull all the data. These are programmatically set up, so they'll run on a regular basis. And so if something happens, instead of, coming up with all these complex, costly, backup plans, let's just pull all it from source data again. And usually in, an hour or two, you're back up and running. And then your last stage is your presentation level layer. Again, there are possibilities. You can do some development and some, front end. We've had some users that want to use SharePoint, Salesforce. It's not really what they're designed for. It could be done, but usually we find it simplest. It gives you the most flexibility to just put a little JavaScript framework type web application in front of this as your presentation layer. So kind of the 4 big pieces of architecture.
That's
So
great.
I'll add on to that. Chris covered so much ground on with this, but I want to call out 2 distinct patterns I've used, at least from the data integration side and the consumption side. So for example, on the integration side of the house, before we get to the persistence, in the last year itself, I did both sort of a centralized approach, where the semantic layer is built on the a central data management platform that the organization may already have, say, such as Snowflake, Databricks, or whatnot, and the semantic layer lives on top of that. So someone has already done the plumbing work of getting all the data into one place. You just build a semantic layer on top of that. All right. The other one is a lot harder, which is more of a federated approach. And even then, you can have 2 paths there, right? You could have a pull-based mechanism, right, where you have a central data engineering team responsible for managing all the ETLs for pulling data from the different applications and then conforming that to the central ontology and then pushing that to the graph. The one that's becoming more popular in my mind, because it's a lot for one central team to know about all the application schemas in the organization, is the push-based mechanism. All right, so there's something working on right now is where the application providers essentially push their data in JSON-LD format into the Kafka topics. But what the central team is responsible for is validating that incoming data against the central schema, right, before that's pushed to the graph. All right, so that's much more scalable because now the responsibility of the central team is much more bounded. On the consumption side, piggybacking on what Chris said, I've done in the past direct Sparkle integration with the clients or whatnot, but of course you can't expect all the different consumers to be smart on Sparkle. So oftentimes we do expose all the graph content through REST APIs, GraphQL. A lot of the graph vendors also ship with BI connectors to support the reporting and analytics need that organizations may have. But one interesting thing I've done in the past as well is this, what I call is the enrichment architecture, which touches both the consumption and the ingestion side. Because say you have your ML models, but the features of the ML model is pulled from the graph via Sparkle query. So you run a Sparkle query against the graph, you have a tabular data set that acts as your features to your ML model, and then you output a label, right, which gets back to the graph to enrich the graph further. So it's almost like a cyclic process there. So there are like different integration patterns and architectures that we have leveraged over the years, but really depends, again, goes down to what problem we are trying to solve and how the enterprise architecture, the reference architecture in the organization is set up.
Yeah, if I could just add into that, Urmi brings up a good point with the push-pull, because that, comes in a lot. And my preference had always been for more of a pull, because it gets a little difficult when you're doing a push, is that then you become dependent on the source system. So those, whoever is that owner, the technical owner of the source system, they're now involved and they have to set up their code so to be able to send, data to your application. When that happens, we've usually, maybe do something like create an endpoint. So all they're doing is really, posting to an endpoint. But when possible, when you have the tools that you need, so there's a robust API in that source system, I always find it better that, as long as they can, you'll need some support from the system owner and, getting access and, client secrets or whatever, how you're actually going to access that data. But then, you have a more control, you're not burdening them as much, and you're, pulling in the data when you need it, as you need it. So another consideration when you're kind of trying to figure out the pull push mechanism.
Right. I can add it just a bit while we're still on this question. And I'm glad, Chris, you mentioned content too, content and data. I know sometimes we're switching back and forth, but there is a difference in the architecture because content lives in content management systems and related, and it's going to stay there. So what's connected is the metadata, and it's connected with APIs, whereas data in databases that actually can be extracted with the extract, transform, load pipeline. It can be virtualized. The data can then actually live within the semantic layer as well as part of a knowledge graph. And we're not talking about knowledge graphs too much, but the definition of knowledge graph is usually taxonomy and ontology and instance data. But we draw the line with content. The content's still staying in the content management systems and, and digital assets in their digital asset management systems. So I just thought I'd add that point.
Great point, Heather.
Yeah, that's really helpful. Okay, so we've learned a little bit about the components and then approaches to architecture, different types of architectures that might be built. Now we'll talk a little bit about why use semantic layer technologies. So the question here is, how do semantic layer technologies address different knowledge management or information management or even data integration challenges? What are some of those technical challenges that you're seeing coming from your clients? And, where have you seen the most impact with using semantic technologies to answer those challenges? Heather, I guess we'll start with you again, right? We'll boomerang back.
Yeah, okay. If it hasn't been stated already, really the most obvious solution and reason for semantic layer is to kind of cut across silos of content or data with this, interconnectedness. So, you might think of, oh, there are all these different systems and they're like silos, and the semantic layer is connecting across. So then what you need to do, of course, is to link. Well, basically what you'd have is you may have had some taxonomy or metadata for each of these different systems and repositories, and then it's that needs to be linked. The taxonomy concepts themselves, and the metadata values through. Sometimes we talk about crosswalks when we talk about metadata. We talk about linking and mapping when we talk about taxonomies, but it's the same idea. Yeah, I mentioned SKA, Simple Knowledge Organization System. It even includes within that data model something new that didn't exist before in the world of taxonomies and thesauri, which are called these mapping properties, or links for linking across different taxonomies. So you can link to equivalences, and or you can actually link, broader or narrower match as well, and you can extend, and there are different approaches. You can, in fact, have then one supermaster taxonomy that other separate ones are linked to, or still have one that have separate ones for their purposes and then link to different front-end taxonomies. And an ontology also is a way of linking multiple taxonomies or multiple metadata term sets as well, by creating kind of semantic special relations across different taxonomies. But instead of just being a match, it's actually saying this, what semantic meaning, adding more meaning. So that, for example, location, could have a taxonomy of geographic locations, and then another taxonomy of organizations, and then it's what is located where, for example, or products and their components, what goes into what, and have these more complex relations. But challenges, just because the technology enables this, it's still, what's the best practice for mapping, for linking? Is something equivalent or is it not? I mean, that's very subjective, and that's what, things that we taxonomists and ontologists grapple with and advise and go through. So let's see, other challenges. I mean, we are seeing increasingly, standardizing on semantic web standard data model. So that's definitely easier, but still, I mean, just because an ontology is built according to web ontology language standards. It doesn't simply easily convert and link to another one. There are all these nuances with ontologies. So that also does sometimes require some intervention by ontologists to, you know, dealing with the data and make it relate better. So I think I'll stop with that and let someone else chime in.
Makes a lot of sense. Chris, if you don't mind, I'll pass it over to you. Maybe you can share an example of a use case that you've worked on and with these semantic layer technologies and what kind of value that provided or what the impact was.
Sure, Sara Mae. Yeah, so I have seen a very common and prevalent issue in my last few projects. So for the longest time, software systems were built, you know, very purpose built for a specific, you know, reason, very, you know, bespoke solution. And you know, they created these silos. We've all heard about these silos, and then along the lines, you know, I'm a search guy. I love search, and so one of the solutions, okay, let's put everything in search, and sure, that worked to some extent, but you know, you were still kind of just moving that silo into the same, you know, into a similar place. Now you had a bunch of silos living together. There was really no connectedness or relatedness between your data, and that's what we're seeing is really key for organizations now. They have knowledge assets or entities or these business objects that are important to them, that are about their real world, but there's no one system that they live in. They live in multiple systems, and they need a way to be able to connect and holistically view those objects. And this is something that the semantic layer helps accomplish. So for instance, with the client I'm working with now, a large international investment firm, to compile information on a deal previously took them, you know, multiple days of asking around this system owner, this system owner, this system owner, and kind of gathering all this content. So they had their information on deals were in one system, kind of the metadata about the deal. The financial information was in a set of databases. The performance data on those investments were in a separate financial system. The people that worked on the investments were in a kind of their HR or their directory systems. And then you know, there was a series of key documents that were kind of developed organically during the lifetime of the investment, and they were in a separate system. And so they really had no way to do this. And so we worked with them through the semantic layer of pulling this content and providing this kind of holistic, unified view, so that now, you know, they can come to an application and in, you know, a couple seconds after a search, be able to see, you know, a deal or investment and all the important parts about it in its fullness, that before they had to kind of collect on their own. And so this is, you know, we've seen this at a large retailer that we worked at, working with their learning content. They were having a hard time viewing all their different contents and topically what it was all on. And so, you know, it's just something we're seeing over and over again, this ability to provide these kind of unified views into those things that are really important to an organization.
100%, like exact same approach, but different different domain, right? Like semantic layer is so good at breaking down silos, right? That what Heather pointed out, what Chris pointed out, and I faced that with in the risk management space last year, right? But whether it's regulatory reporting for the financial sector or regulatory reporting for the FDA, right? So when you time to assemble these reports, similar to the deals, that investment deals that Chris is talking about, there's like a mad scramble to go to all these individual systems, get all the relevant data, you know, put it all together. The fact that semantic layer can bring it all together, bring all the information and put a business context around it, makes that job so much easier. So yeah, I have to agree that you know, that's have been probably the most impactful use case we have solved over and over again at EK.
Mm-hmm. Yeah, I didn't give any example, but with taxonomies, I do remember one project I did a few years ago where the client needed, they already had a taxonomy for their public website, but they needed a taxonomy for their intranet, which was based on SharePoint. And the question was, do they reuse the one and just expand it that they already have? And then some concepts are relevant for the intranet and some are relevant for the public website, although a lot are the same. Or do they have two separate taxonomies and link them? And this was, we had a lot of discussions on this because you really could go either way, and there are advantages or disadvantages. So I won't say exactly in one case it should be one way versus the other, but that's something that needs to be worked out.
Yeah, that's a great point, Heather. And that actually brings us to the next topic we wanted to make sure we cover. So we talked a little bit just now about the value of semantic layers and the impact that it can have on different kinds of work that you're trying to accomplish, but want to give people a sense of like what are the challenges, considerations, or limitations that they should keep in mind when they're thinking of bringing on semantic technologies or going into implementation. You know, do you have advice that you'd give other architects who might be a little hesitant about embracing these technologies?
Yeah, so a couple thoughts come to mind, a couple memories, experiences I've had. One is that, you know, I would recommend our friends in the IT world on the call to really, if you haven't already, start to study graph, embrace graph, see you know what it is. You know, for the longest time we've been so comfortable in that kind of relational database world. We know how things work in SQL, and it still does things well. There are use cases where, you know, relational is still going to be much better than graph, but you know, honestly, there are other, you know, use cases, you know, even some very prevalent use cases where graph is a little bit, you know, it's probably a better fit. And so, you know, there are kind of a couple different types of technologies there. One is kind of the property graph, which I think is kind of graph on training wheels. That's where I like to start. It's, for those of you that aren't aware, that the query language cipher is a little bit more akin to SQL, so a little bit of an, you know, easier into your path. Once you get to some of the semantic stuff that Heather and Urmi are doing with RDF and Sparkle, I kind of makes me shiver. But so I would definitely look into it. I think it's, you know, Google uses it, Meta uses it, Amazon uses it. Like, you know, graph is going to be around. It's here to stay. So maybe better to embrace it than try to resist it. The second would be, you know, kind of thinking that there are out of the box tools available for all this. Yes, there are. They should be leveraged. We all understand that everyone's busy, that there's a little bit of a fear, you know, trying to, oh, I've got something else I need to support that's, you know, been developed, but your developers are important. There's always going to be a need for developers to, you know, because there's always going to be things that aren't quite as easy to do, that are going to take some custom code to do, whether it's in the way you pull the data or display the data. And so I would just kind of, you know, when possible, sure, let's use some out of the box tools, but know that, you know, these are complex solutions, and it might be, you know, really difficult to get what you want without delving into some development time.
Yeah, I'll build on what Chris said about embrace graph. So assume that I'll talk about the operationalization side of the house, right? So you've embraced graph, you've done a very successful POC. Now you're ready to take that into production, right? And you've also chosen some vendor, right? How Chris talked about out of the box tools there are that gives you a good head start, but you may have to do some customization, some additional development, etc. on top of that. But you have chosen a vendor, whether it's the Tom's vendor, data catalog vendor, a graph vendor, whatnot, right? But now you are ready to take it to production. How do you get there, right? So there are many considerations around that we should be aware of. Say starting with infrastructure. So you probably at your organization, you know, already have a strategy for deploying solution, whether it's in your private cloud or in a public cloud like Amazon or Google or Azure, or even employing SaaS offerings, right? So whatever it is, and whatever tool you're trying to buy, it needs to align with whatever the organizational strategy is, right? So infrastructure is big. Security is another big deal, right? You'll probably have existing identity providers in your organization. You have existing entitlement engines in your organization. So whatever new tools you're bringing in, they need to be able to integrate with all of that and support requirements you have around two-factor authentication, SSO, and whatnot, right? So looking into all those technical requirements, non-functional requirements is really key, especially, as you go into production, you have to pay attention to scalability, your what the failover policy is, what is your disaster recovery policy, and how the vendor's disaster recovery strategy aligns with what you have laid out for the organization, how much user concurrency can the vendor tool support, and what's your organizational policy around that. So there is a lot of these non-functional requirements that organizations already have in place that when bringing in the new tool, they should essentially assess that tool against that.
That's a great call. Heather, would you like to add anything here?
Sure. Of course, I would consider especially the taxonomy ontology management tools. Then you need to consider the users. It's not the same users who are involved with data and graph. Right? These are different roles. I mean, those who are more, dealing with, taxonomies, they can have a different background in maybe library and information science and not so much in data, or they even come from some content background. So we think, how many users are going to be and what makes sense for them, and is the user interface easy to, intuitive, especially when we get over into ontology as well. Then I think we touched on this, but with data that's extracted, but with content that's tagged. So you have to deal with the tagging, and the taxonomy ontology management tool will often include some form of auto tagging or auto classification. Now, is this an add-on? Does it cost more? What technology is used? There's different technologies for auto tagging. Often it's around natural language processing, but some is more based on statistical machine learning, and it's good to have already a large set of training content. And the other basic version is by rules, and then you need to write and tune these rules. And often there's a combination, which is great. But this, I think, is a pretty differentiating factor. And then, or you're just going to tag manually. I mean, I'm not going to say, I mean, that's still done too. And especially if the volume of content versus data is not overwhelmingly huge or changing that much. I mean, there's always that backlog problem when you first adopt a system. Okay, we got a backlog of content, but you can, of course, get some temporary indexers or interns to index that. But it's really where you're going in the long term that you need to figure out the strategy. Is it going to be automated, manual, combination? What kind of manual? And is this ideally built into the tool?
Yeah, that's great. One of the things I'm hearing out of that, sort of in the subtext too, is there are some different skill sets that might come along with these technologies. So that's something to consider too as you're moving forward into implementation. Do you have all that covered? Okay, great. So we talked about challenges or considerations. Actually, before we get to our next question or two, our last question or two, I just want to put it out there that if you have any questions, if you're in the audience and you'd like to pose any questions to our panelists, please put those in the chat so we make sure we have time to get to those towards the end of our session. Okay, well, we would be remiss if we didn't talk about the topic of LLMs or generative AI. So we have a question on that topic. How does AI, specifically generative AI or LLMs, impact or work with semantic layers? And Urmi, I'll pass that to you to begin with.
Yeah, I mean, that's the elephant in the room, right? Why are we talking about semantic layer right now when semantic web standards has been around for decades, right? And of course, the answer is LLM. Especially in the last few months or so, we've been seeing increasing interest in GraphRag, right? So RAG is retrieval augmented generation. All these chatbots that are powered, all the organizations are building all these chatbots. They're powered by RAG, and everyone has done their experiments with powering RAG with vector databases with varied success, because how much relevant content you're generating, it really depends on the your chunking strategy, the token limitation you have with the model that you're interacting with. And increasingly, it seems like people are seeing the value of leveraging explicit relationships that you can encode in the graph as part of the retrieval stage of that RAG process, as well as doing the fact checking once you have retrieve the context from the graph, leverage the LLM to generate your answer, and then you can then use the graph again to verify the answer. Furthermore, you can even personalize the answer, right, using all the information you have modeled in the underlying ontology. So it's I would say it's been really impactful with respect to graph RAGs.
Great, and Heather, I'd like to hear from you specifically on the taxonomy ontology realm and how that fits into LLMs right now.
Yeah, well, okay, there are two sides to it. One of them is that taxonomies and ontologies, especially taxonomies, they are built on concepts and their structures. They provide context, and that really helps improve the results that you would get through generative AI, because otherwise, the questions that are put in, if there's not this context, if it goes through the question and also the answers and back and forth with the taxonomy, the results are better. I've seen results of experiment one of our partners had done with this. And then, of course, the question is, oh, can you use generative AI and LLMs to build taxonomies and ontologies? And yeah, I and others in the field have done some experimentations with parts of it, and it does work for certain tasks, not the whole thing, as in, putting a list of concepts into a hierarchy, again, providing some context. And that's why it's better to use your own resources and RAG technology rather than just what's on the open web, because you have that context, especially for hierarchy. And another example would be, suggested synonyms, alternative labels for a concept. Yeah, I mean, I've even experimented, we were talking about Sparkle queries, just so that's the query language for semantic web standards, RDF and SCOS and OWL. I don't do it that much, so I don't really, know it well, so I need a little help. And I think I did some experiment that generative AI does help with some coding, including Sparkle queries. So if Urmi would argue who does the queries better, but I did a little test and that helped too. So there are these little pieces, but just regular AI, not necessarily with LLMs, does help. There are technologies to extract terms from a body of content, which is also a good way of starting to build a taxonomy. But it's also important to get input from users, and this is without AI talking to users, how it helps them. So it's never going to be fully automated.
Yeah, and if I could follow up just a couple ramblings on AI. So one, I think be aware that not every AI project has to be a Gen AI project. About 5 or 6 years ago, one of my first projects at EK was we built a recommendation engine, graph-based, for a development bank that obviously ChatGPT wasn't around at that time, and so have a use case. A use case is not can you build this with ChatGPT? That's probably not a great use case. Sara Mae and I just spoke at a conference a couple weeks ago, And I was a little bit surprised. There were a bunch of information architects, I think, who are maybe naturally a little bit skeptical, but they were very wary of, what, Gen AI and LLMs, and, you hear all the talkers about, hallucinations, which are, very real. And so, we did a little bit of an experiment where, I just went to ChatGPT and I said, the ocean is, and kept on repeating that. And I would get things like, green and vast and wide and salty, whatever. But, I never got pear or porcupine or avocado, so we know what it's doing, it's predicting, but there is something there, so so I would look at it, maybe you're a little bit skeptical, but yet very inquisitive, and know that there is something there, and this technology does have some promise. I kind of liken it to I'm a kind of a wannabe cook, and so as a solutions architect, I'm putting together a meal, and I have many tools to use, and so maybe the LLM is my chef's knife. So it can be very dangerous. It can cut you if you're not careful, but if you use it with care and expertise and experience, it's a very valuable tool to have. So
Yeah, the operating board is human in the loop, right? So especially in very risk-averse industries, right? So it gives you a legwork, gives you a basic set of information to build on, but you cannot just blindly use that information in your production system. You have to involve your domain SMEs to make sure all is good, everything generated by the LLMs is good to use before you deploy them.
exactly. And learn chunking and embedding. Those are going to be two of your favorite words when you do Gen AI. So chunking is basically, how you're breaking up your content into, manageable, understandable fragments that work better with these types of solutions. And then embedding is how you're actually converting those from that text into the numbers, how they've been trained and so forth. So very, very, very common things you'll be dealing with.
Yeah, so that's actually one of the biggest challenges we often see with customers, right? Because when you're creating these embeddings, there is information loss, and depending on how big the your original PDF document, whatever the source document might be, is, and you're trying to essentially contract that into a set of numbers, there is a lot of information loss. And so when you're doing those incoming query, convert the vectors, do cosine similarity against these vector forms of these large PDF documents, there is not a whole lot of match because of that information loss. So chunking and how to capture more, a bit more information than converting the whole PDF into one vector, or summarizing that. That's also another way that information can be lost. So that's very good point to call out, Chris, that you have to play around with your various chunking strategy and see which ones work the best.
Great. Any other thoughts on Gen AI or LLMs before we move to our final question? Okay, well, I think this will be an easy one for you because I know you all are doing great work in this space. But we just want to hear, what are you most excited about in this space? When it comes to the evolution of semantics and advanced capabilities, what are you thinking about here? Urmi, I'll pass that to you to begin with.
So I am most excited about the role that I hope Semantic Layer can play in this big data democratization movements that's happening in many large organizations, right? So there's a big push to make all of the organizational data assets available to all the employees, right? Especially the business, so that they can do their they can really leverage that data for data-driven decision making. And back in the day, you would have to rely on dev or analysts to be able to do that, because they wouldn't be able to really be able to access all that technical information. But because Semantic Layer is so good at abstracting out all the technical complexities and adding the business context, it's much more, it makes the data much more accessible to the business, and then it also in the end improves trust in that data, right? So I'm really excited about how Semantic Layer is going to really play a big role in this movement that has started in the last few years.
Thanks, Urmi. Heather, over to you.
Well, I've been a taxonomist for a very long time, and we used to have to explain what is this, and now there's just a much greater recognition of taxonomies, ontologies, and semantics, and we don't have to tell this is something new that you need. Now we're at the next level. It's like, how do we improve our taxonomies? How do we connect them? And so yeah, the type of services we offer, it's not just design a taxonomy from scratch. It's like help expand our taxonomy, help connect it, help extend it to an ontology, and that's great.
Yeah, absolutely. Okay, Chris, let's hear your what you're most excited about.
Yeah, a couple things I'm excited about. One are kind of the potential with these language models to get domain specific, kind of purpose built. So, I think Bloomberg is doing something in the financial, wouldn't it be great to have a language model that was trained on 10Ks and 8Ks and prospectuses, so it really understood, that language, which is obviously much different from normal everyday language. I'm a huge sports fan, and I've read about the Texas Rangers, who just won the World Series, they developed an application to feed in a bunch of player data and get sentiment about those players as to whether they'd be a good fit or not for their team. Or there was even a paper that I didn't read but came across of, predicting tactics in football. Could you use an LLM for that? So I think there's a lot of excitement over, now taking these generalized and getting down to some specific use cases. And then also as a search guy, I'm really excited about where we are with search right now. We're at a crossroads where, you've had the traditional kind of keyword lexical type search giving way to now the capabilities with vectors and semantics. But beyond that, just the relevancy part of the algorithms, understanding that search isn't just documents, and that there's a lot that you can glean from your data that you can then put into a search engine and get real cool displays like knowledge panels and things like that kind of serve as like those in the olden days, what we did with best bets. So I think there's a lot of potential there that I'm excited to see. I think every search results page should have knowledge panels one day that really kind of show you those really important knowledge assets that we talked about earlier that are built across all your domain.
Great, thank you so much. So that concludes our panel discussion piece. We're going to open it up for a couple of questions here. So I'll pass it off to Madeline to share what questions we've heard, and then we'll close out for the day. So thanks again.
Sure, thanks, Sara Mae. Looks like we have one question so far. So the question is, have any of you created any enterprise data catalogs in a system of multiple knowledge bases? Do you have any comments on how to do a hackathon project, which might prototype an example for leadership to consider integrating into SharePoint and OneDrive?
I'll take a stab at it, Madeline. I can't tell if it's two different questions. The hackathon question is separate from the data catalog implementation question, but I'll take a stab at it. So yes, we have done data catalog implementations where we have brought in different content repositories. A lot of the times, these vendor tools, like the data catalogs that the various vendors have, they ship with connectors for various knowledge bases, so that makes it easier to pull the physical layer metadata, the data dictionary, from the tool itself, and then you go on to build the metadata and the logical layer, as well as the business layer within the catalog solution. As for the hackathon, I would encourage you to kind of start with a very limited scope problem, right, with a very small corpus of data, but make sure it has sufficient variety so that you are pulling in different types of metadata in order to show value for whatever use case you pick, but mostly focus on a very, very limited scope.
And I would just add one thing to that, primarily kind of with the SharePoint and OneDrive. Microsoft is great. I think we found it when you're kind of just playing in the Microsoft world, but we find it very frequently that there are other tools that and data that you want to integrate with your Microsoft. And so we kind of find it better to do it outside of Microsoft and pull the content from Microsoft into, you know, what we're developing outside of it versus trying to pull the stuff from outside of Microsoft into the Microsoft world. That's just kind of some anecdotal experience that I've had. So one thing you might want to consider.
Great question, great answers. We got a thank you from the person that asked the question. Since there are no other questions in the question box, I think we will go ahead and close out. Thank you, Sara Mae, for moderating, and Urmi, Heather, and Chris for your insights and stories today. And thank you all to all who attended this webinar. We hope it was valuable. Our next upcoming webinar on the semantic layer is Thursday, May 23rd from 2 to 3 p.m. Eastern. And our EK experts Lulit Tesfaye and Mariam Nozari will be exploring the role of the semantic layer as the underpinning for AI and machine learning technologies. Participants will learn about the synergies between the semantic layer and AI and how this integration is shaping the future of business intelligence and analytics. So we've dropped a link in the chat if you're interested in registering for that session, or you can always check out our Enterprise Knowledge LinkedIn page for more information. And thanks again.
Thank you, everyone.
Thanks, Mel.